To understand continuity, we need to determine one-sided limits. Now, so far we focused on two-sided limits, where the limit of f of x equals L as x approaches some value c. However, we can also approach from the left side. Notice there is an exponent. It looks like a negative sign for an exponent. That means the x, we're approaching the function from the left-hand side of c. A right-sided limit, this is read as the limit of f of x equals L as x approaches c. From the positive side, you'll notice there's a positive sign where the exponent normally is. Let's look at a specific example. If we want to find the limit of f of x equal to the square root of 2x minus 1 as x approaches 1/2 from the right-hand side, what we would want to do is fill in the graph. And if we do a couple values, we wind up with a graph that looks like this. Notice this is a parabola that is on the side, but it's only half of it. The reason it's only half of the parabola is because the other half would make this not a function. And things need to be functions to make them nice for us to work with. Now, we're interested in what happens as x approaches 1/2 from the right-hand side. Notice as x takes a value and gets closer and closer to 1/2 from the right-hand side, what is the y value doing? And one technique is to simply substitute in to see what happens here. So if we replace x with 1/2, we wind up with the square root of 1 minus 1, which is the square root of 0, which is 0. Now, this makes sense, and we would write this as the limit of the square root of 2x minus 1 as x approaches 1/2 from the positive side is equal to 0. Please notice that we could not come in from the left-hand side and have a left-hand limit because the function is not defined. This is a very important concept as we build on analyzing continuity in its different formats.